Hi guys, welcome to my YouTube channel, and in this video I will briefly discuss about Gauss's law. This is very important law in the topic of or in the chapter of electrostatics, in which we will consider that or we will draw a arbitrary or irregular shape in which electric field points or charge points or test charge are placed arbitrarily distributed in that shape. This shape is not regular, which is irregular shape, and we cannot justify that, or no one can question that this is a regular shape or we are placing a regular charges. So every charge has a distribution point which is known as q1, q2, q3, q4 and q5 and etc. In order to understand this, every charge has a flux. In order to understand this, every charge is producing a flux because number of electric field lines passing through any body or number of electric field lines passing through any area become a flux. In order to better understand the Gauss's law, we need to calculate the flux of every charge. So every charge, for example Q1 or flux 1 related to Q1 will be Q1 over epsilon naught 1, because this formula is previously discussed in the last topic. So for charge Q2, the flux will be Q2 over epsilon naught, and this epsilon naught is a permittivity or free permittivity of free space. So similarly for charge 3 and for charge 4, every charge has a flux, and its distribution can be found in this example. So Qn for n charge, Qn is over epsilon naught for the flux for nth charge. So in order to understand this, or we want to calculate the total flux produced in that body, or this body is irregular shape, and we need to calculate the or we need to formulate the formula in order to understand the total flux in the irregular shape of the body. So the total flux can be find out, and I have written a total flux is equal to question mark, and we need to calculate the total flux. We know that the flux has a formula phi E is equal to Q over epsilon naught. So for charge 1, the flux will be Q over epsilon naught. For charge 2, Q2 over epsilon naught. For charge 3, Q3 over epsilon naught, and so on up to charge n, which will be Qn over epsilon naught. So in this expression you have seen that this 1 over epsilon naught is common, can be taken as common from all the expressions. 1 over epsilon naught taken as common into the remaining term will be q1 plus q2 plus q3 up to qn, because these are the distribution of charges in the arbitrary distributed in the irregular shape is given in the previous things. So epsilon phi E or total flux or electrical flux is equal to 1 over epsilon naught into total charges, number of charges. It will be total charge contains in that body or in that irregular shape of the body. Furthermore, in order to understand this, because that body is enclosed with a lot of number of charges, so if we add all the charges, it will become a total or whole charge containing that body. So the total flux or formulation of that flux in that irregular shape of the body will be electric flux is equal to 1 over epsilon naught into Q, with this Q or capital Q will be denoted as a total charge placed or total charge contains in that body. Furthermore, in order to further understand this, or we want to make a definition of the Gauss's law, which states that the total flux containing the irregular shape of the body is equal to 1 over epsilon naught. As you have seen in the this expression, it will be 1 over epsilon naught times into total charge contains that body is equal to total flux. This is known as Gauss's law, and this law is very helpful in order to understand the total flux, or in order to calculate the total charge if we have a flux. And if we have a flux of irregular shape of the body, we can find out the charge in column, or we can also find out the flux, number of electric field lines passing through that body. It will be total flux. So the Gauss's law states that total flux is equal to 1 over epsilon naught times the total charge enclosed in that body. This is the final expression or final statement of the Gauss's law. And this law can also be asked in the intertest questions, because this is very important law in the electrostatic, and most of the intertest questions are asked related to total flux and charge contain that irregular shape of the body. And in the next chapter we will explain the applications of Gauss's law, in which we will discuss the infinite sheet having cylinder or charge placed in the hollow sphere. Up till now we have finished about this one, and if you have any question related to Gauss's law, electrostatics and electric flux, you can contact me at my email address, and you can contact me at this, my contact number is given, and we will see you in the next video. Up till now,